Okay, I got this problem from Alex here, and it says gaseous methane reacts with oxygen O2 to produce CO2 and water, typical combustion reaction. And it tells us that if 8.07 grams of carbon dioxide is produced, that's how much we actually got from this reaction in the lab, from reacting 8.81 grams of methane and 19.9 grams of oxygen. Let's calculate the percent yield of carbon dioxide. So I can see from reading this, I'm given two quantities of the reactants here. This is going to be a limiting reagent. Whenever I see the term percent yield, I need to find out what that limiting reactant is. First thing we always have to do is write down the chemistry, so let's do that. We have, if I can on this pad, CH4 plus oxygen, a hydrocarbon and oxygen will burn to give us CO2 plus water. That is the chemistry that's going on. I have to balance this thing. So let's see if we can look real quickly and balance that. I know if I put a 2 there, and if I put a 2 there, I think that's going to balance for me, and so it does. So this will give me my stoichiometry. 1 mole of methane produces 1 mole of carbon dioxide. 2 moles of oxygen gives me 1 mole of carbon dioxide. So let's go ahead and write down and set this up how I would do it. So the first thing I have is I have 8.18 grams of methane. So I'm going to start with, and then down here I have 19.9 grams of oxygen. Those are my two reactants. And so let's we could choose either of the products that we can use our stoichiometry to get the limiting reactant, but because I read in the problem that we need to find the percent yield for carbon dioxide, let's make sure that we choose this as the product that we're going to use for both methane and oxygen. So let's get going. Never, never, never leave it in grams. We always have to go to moles. And so I know that there are 16 grams of methane in 1 mole of methane, CH4. Alright, now I'm into moles of methane. Then I know that for every 1 mole of methane, then I make 1 mole of CO2. So let's go ahead and write that. For every 1 mole of methane, then I produce 1 mole of CO2. Okay. Finally, I want to get that back out into grams because we're doing a percent yield. I know that for every 1 mole of CO2, because I've done this many, many times, there are 44 grams of CO2. Alright, let's see if our units cancel. They do here. I have to ask myself, is this a true statement? For every 1 mole, that's a 1, not a 7. For every 1 mole of methane, are there 16 grams? That's a true statement. Okay, now I look down here, my units cancel, and for every 1 mole of methane, do I produce 1 mole of CO2? That's what my chemistry tells me up here, so that's true. And finally, my units cancel, and this is definitely a true statement. So when I do that math, how much CO2 would I produce from that amount of methane? Then I would produce, if I do the math right, 22.5 grams of CO2. That's how much comes out if 8.818 grams of methane were there with excess oxygen. But now we have to take account for the oxygen here. So again, let's get that thing into moles. I know that there are 32 grams in 1 mole of oxygen. And now I have to look at my stoichiometry. There are 2 moles of oxygen that it takes to produce 1 mole of CO2. So I write down 2 moles of oxygen will produce 1 mole of CO2. And again, I want to get that out to grams. I know that for every 1 mole of CO2, then there are 44 grams of CO2. And if I do that math, how much CO2 do I produce? I produce 13.7 grams of CO2. This, because it forms the least amount of CO2, is the limiting reagent. That is, oxygen would run out first when these two quantities are reacted with each other. Oxygen is the limiting reagent. The theoretical yield is 13.7 grams, but it asks for the percent yield. Well, in the lab it says that we collected 8.07 grams, and so I'll do my percent yield up here. So percent yield equals the actual yield, the 8.07, divided by the theoretical yield, which is right here, 13.7 grams times 100 to get that into percent. And when I do that math, I'm going to put my equal sign right here. I get out of this 58.9% yield. This is the right answer. So again, to review, write down the right chemistry, balance the equation, don't forget to do that. Start with both of your reactants here. Make sure you get them into moles. You have to get that into moles. Then do the stoichiometry. This right here is the stoichiometry right down here. And then finally we'll get that back out to grams. This is the theoretical yield. Percent yield is the actual, which came from our problem up here, divided by our calculated theoretical yield. And then multiply that by 100. That is how you do a limiting reagent problem as well as a percent yield problem.